Hello students, how are you doing? I hope you guys are doing great. And today we are going to see the paper discussion of 21st Jan shift 2. So are you ready for the session? Okay, so without wasting any time, let's start. In question number 26, we have the considered two identical metallic spheres. So we have two identical metallic spheres. Sphere number 1, sphere number 2, and sphere of radius r, charge q and mass m. So radius is r, charge is q and mass is m, and both are having the same quantities. And then question says their centers have an initial separation of 4r. This separation is given 4r. Okay, both spheres are given one initial speed u towards each other. So in this problem we have two simple spheres and those are separated by 4r distance. Those are approaching each other with u velocity. They both have u velocity. Okay. Then the minimum value of u so that they can just touch each other. Okay, k equals 1 upon 4 pi epsilon naught, and assume kq square is greater than gm square. So let's start this problem. This is nothing but a problem of energy conservation. How, sir? So question is saying they are approaching each other and they collide. So the minimum velocity of u so they can touch each other. Now there is no separation. That means distance between those is 2r. Now calculations are pretty easy. Apply energy conservation. According to energy conservation, initial energy will be the final energy. Initial energy, kinetic energy. The mass one has kinetic energy half mu square. Second one has the kinetic energy half mu square. So sum of kinetic energy is mu square. Okay, simple. Then potential energy, but it has two kind of potential energies. First is electrostatic. So electrostatical potential energy is k q1 q2 by r. So separation is 4r. Okay, now you know potential energy for gravitational force is minus g m1 m2 by r. Let's apply that here. So that will be minus g m1 m2 means gm square by 4r. Final. Now final kinetic energy will be 0. We are giving just velocity so they can touch each other. Okay. Final kinetic velocity is 0 and potential energy electrostatic, that would be kq square by 2r, and gravitational potential energy will be gm square by 2r, right? Now let's do one thing. From here what will be the value of mu square? Mu square value would be, here we have kq square by r, 2r. So let's say kq square by r is x. So this is x by 2 and this value is what? kq square by 4r, x by 4. X by 2 minus h by 4 will be what? X by 4. So kq square by 4r. Similarly, this is what? Let's say gm square by r is y. So y by 2, this is y by 4. So minus y by 2 plus y by 4. So minus y by 4 minus gm square by 4r. Okay, now question is pretty easy. So we need the answer in the terms of where kq square by mr is common, but we have 4r. So let's do one thing. First of all, we have a mu square. So could I do one thing, that instead of here I could write that m here, m and m. Simple, because if here it is in the numerator, in RHS that will be in the denominator. Simple. So Then take common kq square by 4mr. Now 4mr is common. So u square is kq square by 4mr. Okay. Here we have 1. Here we have gm square upon kq square. Array yes or no? Simple thing. Kq square. If you want value of u, then that would be root of this value. Array, if I say that, sir, what would be the value of u? So do one thing, the under root of this value y will be the answer. So answer is option number C. I hope you guys understood this problem. Okay, now we are approaching the second problem, that is question number 27. Okay, third is the correct answer. In 27th question we have the charge stored by the capacitor C in the given circuit in the steady state is in the microcoulombs. So in steady state we know that it cannot flow any current. Okay, so here we don't have anything, simple, and this will behave like a wire. Okay, so now first of all let's talk about this outer circuit. In outer circuit we have 2.5 voltage, 1 ohm, 4 ohm. Total resistance 4 ohm and 1 ohm are in parallel combination. So the net resistance would be 5 ohms. So I current would be what? I current in this circuit would be 2.5 upon 5. So 0.5 ampere. Okay. So we have current 0.5 ampere in this circuit. So then if this point is A and this is B, so if I talk about VAB would be what? 2.5 minus IR. I current is 0.5 and R is 1 ohm. So basically VAB is 2 voltage. But what do we need? The steady state. Okay, we need charge. Now in the steady state the charge flowing will be 0 in this, because once it gets charged then current will be 0 in this. So whatever VAB we have, that VAB will be here. Yes or no? The same voltage difference will be here, and if charge flow is 0 means current is 0, then if this is V, so this would be what? This point will be V minus IR, but here current is 0, so V, so VB, VA. So we have 2 voltage across this capacitor. If you have 2 voltage across the capacitor, so could you tell me the value of charge? So value of charge is CV. See, now capacitance is given 5 microfarad and voltage is 2. So answer would be 10 micro, okay, coulomb. In micro, okay, great. So answer would be the option number 2. This question is also pretty simple. See, level of the questions is simple if you know the concepts very well, right? Now question number 28. The total length of potentiometer wire AB is 50 centimeter. Length of wire is given 50 centimeter. Okay. Then in the arrangement as shown in the figure, if P is the point, now this P is the point where the galvanometer shows 0 reading. 0 reading means what? This, let's say this is R1, this is R2, R3, R4. So in the case of 0 reading, you guys are aware that R1 upon R3 should be R2 upon R4, because these should be also in the same ratio. So could I say these resistances will be in the ratio of 6:4 or 3:2? Okay, now we need AP. So total length AB is given, AB is 50 centimeter. Okay, so 3:2 means total portions are 5. Let's say 2 portions and 3 portions. So each portion has length. So that each portion length, let's say this is AX. So AX will be 50 upon 5, 10 centimeter. But in AP we have 3 sections. If we have 3 sections, then that value will be 3 times of 10. 3 times of 10 centimeters would be 30 centimeters. Option number 3. Understood? Understood? Simple. Problems are simple. Now next is a capacitor C is first charged fully with potential difference of V naught. So question is asking, we have this that's what capacitor, and that is fully charged by V naught voltage and its capacitance is C. Okay, and disconnected from battery. Okay, the charged capacitor is connected across an inductor. So we connected this across inductor. Okay, initially it is charged with V naught voltage. We have that data. Okay, and its inductance is given L. Okay, in t second 25% of initial energy in the capacitor is transferred to the inductor. Okay, the value of t time, if 25%, now see carefully, 25% of total energy is transferred to inductor, so it has 75%. Okay, you note initial values, initial energy would be what? Q naught square by 2C. Okay, let's say initially it had Q naught charge. Okay, now U will be what? Q dash square by 2C. Simple. And this Q is Q naught cos omega t. Why I am not taking sin omega t? Because initially when you are putting t equal to 0 second, then Q is Q naught. So put that value here, Q naught square by 2C and cos square omega t, and Q naught square by 2C is U naught, and U is also given, that is 75% of U. 75% of U naught, or I could also say that 75% of U naught or 3 by 4 of U naught equals U naught, this is Q naught square by 2C is what? U naught, and cos square omega t. Simple. Now cos square omega t is 3 by 4. So cos omega t is what? Cos omega t is root 3 by 2. Then this is the value at pi by 6, right? So omega t is pi by 6 and t time is 1 by 6. Okay, pi by 6 and omega here. Okay, now which option is correct? Okay, and you guys are aware that omega is 1 by root LC. Put that value there. So t time would be what? Pi by 6 and root LC. Simple, again simple. So option number 3. Okay, option number 3. So we have seen 4 questions and all the questions are easy. The RMS speed of oxygen molecules at 47 degrees centigrade. 47 degrees centigrade means what? 47 degree means, yeah, 320 Kelvin. 320 Kelvin is equal to that of hydrogen molecules kept at T temperature. Let's say that is T degree centigrade. So RMS speed, you guys are aware that Vrms is root 3 RT by M. Yes, but 3 R are common, and if Vrms speeds are equal, so I would directly say this is for oxygen molecule and that of hydrogen molecule. So in oxygen molecule, this is a diatomic gas O2, and its molar mass of O2 is 32, and hydrogen is also diatomic, simple, H2. So molar mass of H2 is what? That is 2, simple. So I would say that T of O2 upon MO2 equals TH2 upon MH2. So TO2 is given, that is 320 kelvins. Okay, this is 32, TH2 we had to find, and MH2 is given 2. So 16, right? 16, and this is okay. So 16 to the right. So here we have 16 to the 32, 20 Kelvin. If T temperature is 20 Kelvin, okay. So if value is 20 Kelvin, then what will be the value in degree Celsius? So value in degree Celsius would be what? So 20 minus 273. So that almost gives the value, that is 253, I guess. Yeah, minus 253 degree centigrade. Did you understand? Simple. Okay. Now option number 4 is correct answer. Now let's approach to the 31st question. Two cars A and B, each of mass 10 raised to 3 kilograms. Okay, mass of cars is given 10 raised to 3 kilograms, that means 1000 kilograms, are moving on parallel tracks separate by distance 10 meters. Okay, both are parallel and separated by 10 meter, right? Distance between those is 10 meter. Mass of both is 1000 kilograms. Let's write it 1000 kilogram. Okay. Now in same direction with 72 kilometer per hour and 36 kilometer per hour. So 72 kilometer per hour. Now you convert it into meter per second. So what would you do? 5 by 18. Okay. And here we have 36 kilometer per hour. Again you convert it into meter per second. So this would be 10 and this would be 20 meter per second, right? Multiply with 5 by 10, you will get the values. Those are 20 meter per second and 10 meter per second. Now the magnitude of angular momentum of car A, basically this one was A and this is B. So angular momentum of A. Now we are going to use relative motion. How relative motion? See, let's say B is on the rest and A is moving. Okay, so relative velocity will be what? 10 meter per second. 20 minus 10, that is 10 meter per second, and it is in rest. Mass is also given, and that mass is what? 1000 kilograms. Okay, separation is 10 meter. So angular momentum L vector would be what? mvr, simple formula. So 10 raised to 3 into 10, that is 10 raised to 4 into 10 raised to 5. Option number 3. And unit would be what? Joule second. Understood? Again simple problem. See, questions are simple. So in question number 32 we have the pulley shown in the figure is made using a thin rim. Okay, this is a thin rim and two rods of equal length to the diameter of rim. Okay, the rim and each rod have mass m. So this rim basically has mass m. Okay, and this rod has mass m and this also has mass m. Capital M, capital M, capital M. Okay, two blocks of mass m and m are attached to two ends of a light string passing over the pulley. Now here this is capital M, small m. So for both the blocks there will be a gravitational pull, capital Mg, small mg. Okay, which is hinged to rotate freely in vertical plane about its center, the magnitude of the acceleration experienced by the block. So first of all, write all the things which you could see. So you could see one thing, that this would be T2, T1. Now this is not an ideal pulley, so tensions would be not same. But if this particle is moving with a acceleration downwards, so this particle will be also moving. This particle is moving with the acceleration downwards. Yes, 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 yes. So I could say one thing, that acceleration would be A for both. Now simple, just make the equations and question is pretty easy. How? That mg minus T2 equals ma. Equation number 1. Equation number 2, that is T1 minus mg equals ma. These are equation number 1 and equation number 2. Let's do one thing. Let's add these equations. So from here we get m plus small m z and okay, sorry, this is minus not plus, m minus m, then T1 minus T2 plus T1 minus T2. Okay, T1 minus T2 equals, there we have m plus small m a. Now we have all the terms in m, g. So we have to find the value of T2 minus T1 or T1 minus T2. Simple. So I could say one thing, that here we have T1 tension, and you guys are aware that tension is always a pulling force. By tension you cannot push any block, right? You only could pull by using tension. So could I say that T2 minus T1 into R, that is R radius of that pulley, is equals torque. Simple thing. Look at here again. I said that here we have T2 tension, T1 tension, T2 tension. This T2 is trying to pull it down and T1 is also trying to pull it down, but in the other end. So net force is T2 minus T1. So net force into R. R cross F is what? Torque. Simple thing. Okay. Now let's calculate the moment of inertia for the pulley. So in the pulley we have two rods. First rod, second rod. So and they are rotating through their axis. So from this axis we know that moment of inertia is what? ml square by 12. So but L length is twice of R. Okay, length of this rod is twice of R. So could I say total moment of inertia for this would be 2 and L is 2R. So 2 to the 4, r square by 12. Simple thing. Then we have a rim. So for a rim, moment of inertia is directly ml square, right? Mr square. Or so now radius is r, but length is 2r, radius is r. So here we have m r square. Now for 3 is 2 by 3 mr square plus mr square. 2 by 3 plus 1 means what? 3 plus 2, 5 by 3. So could I write that 5 by 3 mr square is moment of inertia for this pulley? Yes, I could. Now simple thing. Torque is I alpha. Torque is I alpha. Now we have one more thing, alpha. So we know that R alpha is tangential acceleration. Are yes or no? And that tangential acceleration itself is the acceleration for the blocks. So that is A. Otherwise I could write AT, but I am gonna use it as A. So alpha is A by R. Simple. Put all the values here. T2 minus T1 R equals torque is I alpha. I is 5 by 3 mr square and alpha is A by R. So we have 1 R. Cancel out. Numerator, denominator cancel out. So now we have that T2 minus T1 value. Okay, that's great. 5 by 3 m A. And that's what you needed. You needed, okay, m minus small m z minus T1 minus T2. But that value is T2 minus T1. So minus 5 by 3 m A equals m plus m A. Now question is very simple. So when this term will go in the right hand side, so we have capital MA plus small m A plus 5 by 3 capital M A. So capital M A plus 5 by 3 capital M A would be what? 5 by 3 plus 1, 8 by 3. So that value would be what? So let me write here m minus m g equals 8 by 3 m plus m A. So A. Now this will go, when it will come in the left hand side, this will go in the denominator, sorry. So answer would be 4th. Okay. See, again simple problem. See, problem is simple, but calculation is hard. We did it in the 4 steps. First of all, we wrote the equations for tension. Then we again added those equations and we got the idea. Okay, I need value T1 minus T2. Whatever I do, I need T1 minus T2 because all the terms are there in the answer. Only T1, T2 term is not there. So T2 minus T1 is providing the torque to the pulley, right? So then torque I alpha. Alpha again, alpha is R alpha. And where that is what? Acceleration, tangential acceleration. So tangential acceleration itself, the acceleration of the blocks, right? Simple. Now next question is, the kinetic energy of simple harmonic oscillator is oscillating with angular frequency of 176 radian per second. Okay. So basically, sir, what is this term? Kinetic energy of simple harmonic oscillator. So does kinetic energy has frequency? Yes, it has. How, sir? If velocity has frequency, see, velocity has frequency, so kinetic energy is what? Half mv square. So it also has it also has the it also has the frequency. Okay, but here we have v square term. So the whatever frequency of oscillations, okay, oscillations, the kinetic frequency of kinetic energy would be twice of this frequency. Now, so value is given for kinetic energy. So first of all, 176 radian per second. 176 radian per second. And this is what? This is angular frequency. This is not frequency, this is angular frequency. And angular frequency is what? That is 2 pi f, right? 2 pi f. So f frequency would be what? 176 upon 2 into 22 into 7. So this value would be what? 176. So 88. 22 4 ja. So 7 4 ja 28. 28 hertz. So that's the frequency for kinetic energy, and that is twice of an frequency of oscillations. So frequency of oscillations would be half of frequency of kinetic energy. So half of 28 would be 14. I hope you understood. Yes. Are yes. See, if you found this answer and you are taking 28, then that is absolutely wrong. So before marking your answer, please recheck the answer. When you are going to give the exam next time, before marking the answer, please recheck the answer. Okay. Given below are two statements. In Young's double slit experiment, the angular separation of fringes will increase as the screen is moved away from the plane. So this is a screen. So what is it is saying? So these are coherent light sources, and yeah, you are aware that there we have wavefronts. Okay, so what's the question actually? In Young's double slit experiment, the angular separation of fringe. Okay, angular separation of fringe. So angular separation, how would you do it? When you marked this, so those lines would be cutting there. So increase as the screen is moved away from the plane? No, that's not the case. So when you are moving away, that will be the similar. So this statement is incorrect. Okay. In a Young's double slit experiment, the angular separation of fringes will increase when monochromatic source is replaced by another monochromatic source of high wavelength. Yeah, if wavelength is increased, cause why? Because you know delta x, path difference is lambda d times d. So if you are increasing the lambda, then that would increase. So this statement is true. So statement 1 is false, but statement 2 is true. Yes. Then a battery with EMF E and internal resistance R is connected across a resistance R. Okay. In this problem, we have a battery, okay, and it has some its internal resistance R, and it is applied across RL. Let's call it RL, load resistance. Okay, so what will be the maximum power consumption by RL, by load? So maximum power consumption, right? So you have already done in your classroom, and this is R would be R. You guys are aware of that answer. So, but how we do? We directly do that. P is what? Power is V square by R, okay, or I square R. So whatever you want, you can apply, and then what would you do? Because this is load, this sign means this is variable. So dP by dr, do it 0. So in mathematics you have studied the concept of maxima. There also differentiation of the curve would be 0. At the minima also differentiation would be 0. So by the concept of maxima and minima, answer would be 2, and this is very simple. So we are moving to the next question. Keeping significant figures in view, physical quantities, okay, these are physical quantities. Now, so let's say you are doing any iteration. So after any iteration, if you have number x, y, z, whatever you have, and a, b, c, x, y, z point a, b, c. So after point, these digits should be minimum. So minimum digits 2, 1, 3. So after point, there should be only one digit. So this would be the answer, option number 3. This is also very simple. Then comes a spherical body of radius r and density sigma. Okay, spherical body, radius of small r and density sigma, falls freely through a viscous liquid having density rho and viscosity eta, and attains terminal velocity. Terminal velocity means what? After it, velocity would be constant. If velocity would be constant, if velocity is constant, that means net force is 0. Net force 0, that means what? Velocity constant. Yes, because acceleration is 0 here, right? So in this case, could I say downwards pull, first of all mg, okay, viscous force F viscous plus bind force FB, FV plus FB equal to mg, gravitational pull, right? Simple. And viscous force is FV. So FV is what? 6 pi eta RV. Okay. 6 pi eta RV plus bind force. Bind force is density of liquid. It is moving in rho dense liquid. So rho V. Let's say V is its volume. So V into G equals mg. Mg means what? Its density is sigma. So sigma into volume is mass, sigma Vg. Now estimate maximum error in the quantity eta. So we need error in the eta. So simply I would do, send it in the right hand side. So there we have sigma minus rho. V volume is how much? 4 by 3 pi r cube. Simple. Sigma minus rho V Z equals 6 pi eta RV. Now I need that percentage error in the calculation of maximum error, not percentage error, in the calculation of eta. So that would be, see, sigma minus rho and 4 by 3 pi G, and let's write R cube in the end. Okay. And here we, okay, this is what? Terminal velocity V naught. And here let's write 6 pi R V naught. Now from here see, could I cancel out this? This would be r square only, and from here eta is proportional to r square by v naught, and all the other things are constant. These two things are variable. Okay, now maximum error. So maximum error would be what? That would be twice of delta r by r plus delta v naught by v naught. Simple. So option number 2. Simple. Yeah. Why we are not taking minus? Because let's say you have 3 things and you are going to do iterations A, B. Now in this iteration you have error that is plus minus 5%. In this also we have iteration plus minus 5%. So maximum would be what? 5 and 5, 10%, and minimum would be minus 10%. Maximum it could be the value 10% higher when you are doing sum, and it could be the 10% lesser. Okay, when you are doing not sum, when you are multiplying it. So that's why when you are adding these two things, so that would be plus minus 10%. That's why we always take plus sign here. Okay. Simple. Now next is surface tension of two liquids having same densities T1 and T2 are measured using capillary rise method utilizing two tubes of inner radius R1 and R2. Okay. So basically these are two capillary tubes and they have different radiuses, and those are inside liquid. Let's say those liquids are different. Those are not same liquid. Then measured using capillary rise method. So you know liquid will be raised here and let's say its radius is r. We are calculating for any r and h height. Rise is h. So you know, but see, this is not the case that this is spherical. This is open. So could I say pen? Okay. Let's measure pressure here. So this pressure is what? P naught minus, I am talking about pressure at this point, P naught minus 2T by R, and that R is radius of that sphere, capital R, and radius for this is small r. Okay. And similarly, if here pressure is P naught, so in the depth pressure is P naught plus rho gh. When you are going upwards, then P naught minus rho gh equals P naught minus rho gh. Rho is what? Density of liquid. Now, so from there h is what? 2T by rho gh. And again, see, so in this case, sorry, this is r radius, okay, and this is r, capital R radius. Let's say this is theta. So this capital, okay, rho g r, sorry, because h is already there. So this r would be what? From there r would be small r by cos theta. Why I am doing this explanation? Because I am going to use this 2T by rho g and r by cos theta. Okay. So if it is given that R1 is greater than R2, but we have tensions as well. Okay. So what's the other thing? Ignore weight of liquid about the lowest point of the meniscus. The height h1 and surface tension satisfy the relation surface tension T1 T2 measured using R1. Ignore weight of liquid about the lowest point of meniscus. The heights h1 and h2 are surface tension. Satisfy the surface tension of two liquids having same densities. Okay. Here we have same densities. That means their tension would be the same. Okay. If their tension is same, then if R1 is greater than R2, then small r is inversely proportional to h, height of the capillary tube. So then R1 greater than R2, H1 less than H2. Option 1. Simple. Okay, good. Now the next question is a river of width 200 meter flowing from west to east. This is river and this is flowing from west to east with 18 kilometer per hour. 18 kilometer per hour, or that would be what? 18 by 5. No, 5 by 18, sorry. So 5 meter per second. So that's the speed of river that is flowing from west to east. Okay. A boat moving with a speed of 36 kilometer per hour. So 36 kilometer per hour means what? Kilometer per hour means, so 18 by 5, no 5 by 18. So 5 to the 10 meter per second. Okay. Minimum time taken. So minimum time taken. In the case of minimum time taken, let me redraw it. In the case of minimum time taken, it should have its velocity, means boat should be concentrated in this direction. Velocity should be only in this direction. If I want minimum distance, then I will move boat in somewhere this direction, and this component will be cancelling out that 5 meter per second. But now completely that would be in the y direction, 10 meter per second. Okay. And separation is given or not? 36, 200 meter in the starting. So separation is already given, that is 200 meter. So similarly in y axis velocity will be constant. Even in x axis as well velocity will be constant. Now that is why sir? Because river is still flowing from west to east. That means what? Velocity in x direction will be same and in y direction also will be same. So t time, so that will move like this. Okay, not like a projectile, because we don't have any kind of acceleration in either x direction or y direction. So it will move in this kind of shape. Okay, and when it is coming back, then also it will come like this. Okay sir. So we need t time. So simple, t time, time of ascent will be the time of descent, because we don't have any acceleration. So time of ascent, let's write time of ascent, and that will be time of descent. So that would be what? So that would be how? So distance, that is 200 meters, separation is 200 meters, speed is 10. So 20 seconds. So this is time of ascent and descent. Total time is 20 plus 20, 40 seconds. Okay. Now in x direction, in west direction also we have same velocity. So range, let's call it range. So range would be UX into T. So UX is 5 into T time, total time period is 40. So 45 are 200 meters. 40 second, 200 meters. Option number 1. Simple. Yes. Simple. Okay, so now let's move to the next question. Next problem is two known resistance of R ohm and 2 R ohm and one unknown resistance X ohm. 2R X R, okay, are connected in a circuit as shown in the figure if the equivalent resistance between points A and B in the circuit is X ohm. Okay, equivalent resistance is X ohm. So let's say equivalent for this series combination would be what? X plus 2R. Okay, so let's call it Y. This is Y. So then, okay, and equivalent resistance AB is given X. So X equals in parallel combination RY upon R plus Y. Okay. Sorry. So X equals R. That is R. But Y is X plus 2R. X plus 2R. Are yes or no? Now R plus Y. R plus X plus 2R. So X plus 3R. Now in the right hand side. So that would be X square plus 3XR equals X square plus 3XR equals RX plus 2R square. Am I right? Okay. So what do we need here? So now we got the quadratic equation. X square equals plus 2XR minus 2R square. You know how to solve quadratic equation. X would be minus B, minus of 2R plus minus. So now I am only going to use plus sign. Now I won't use minus. Why not minus? Because already I have minus and resistance can't be in minus. So I would use plus sign only. If I had plus here, then I would check. But now that's not way. There is not a way to check. Why? Because already I have minus sign. So it must be positive. Okay. B square minus 4AC. See what is B? So B is 2R. 2R square means 4R square. B square minus 4AC. Minus 4AC. 4 to the 8 minus plus 8R square. Okay. So 4R square, 8R square, 12R square. 12 is 4 3s are 12 by 2A and A is 1. So from here X would be there. This would be 4 plus 8. 12. 12 is 4 root 3. No. In the root 4 into 3. So 2 root 3. So 2 root 3. Okay. Minus 2 R upon 2. So basically root 3 minus 1 by 2 R. Okay. 2 is cancelled out, right? Root 3 minus 1 into R. Root 3 minus 1 into R. Option number 4. Okay. Simple. Now question number 41. In this question we have the energy of an electron in an orbit of Bohr's atom is minus 0.04 E naught electron volt. Okay. So you know in the nth orbit energy of nth orbit is E naught by n square. Okay. Yes or no? Simple thing. And in nth orbit energy is given, that is 0.0. And why minus sign? Because electron has minus sign. So minus. Otherwise I am not going to use that. 0.04 E naught. That means what? That means E naught by 25. Right? Suppose this would be what? By 100 and 1 by 25. So could I say orbit is fifth orbit, n square is equals 5. So n is fifth orbit. Are yes or no? And now question is asking what is 2 pi L upon h. Okay. So you need the value of what? So you know, okay, L is what? L is angular momentum, yeah. So you know L is nh upon 2 pi, right? So then 2 pi L upon h would be what? 2 pi L upon h would be what? N, and that we have already calculated the value of n, that is 5. Okay, simple. Now let's move to the next problem. Next problem is, okay, for magnetic field, an infinity long straight wire carrying current I is bent in a planar shape as shown in the diagram. The radius of the circular part is r. The magnetic field at the center of x. Okay, so now let me clear one thing. This is y direction or positive j cap. This is z direction or positive k cap, and this is the x direction. This is the x direction or positive I cap. Okay, now if we have current in this direction, so magnetic field, so I am talking about magnetic field due to infinite long wire on r distance, that would be what? Yes, out of the plane, positive x, okay, due to the wire, but due to the loop, that would be what? Inside the plane, right? Inside the plane, minus x, okay, plus x, minus x. So plus x is due to wire. Now due to wire we know, due to long wire magnetic field. Now we are calculating total magnetic field. Due to long wire, mu naught I by 2 pi and r is r, small r, and this is in positive x and that is in minus x. So let's write here only. So that value is mu naught I by 2r, we know, and I cap. Okay sir. So what we need? Mu naught I by 2 pi r, simply, and in the bracket we have pi minus 1. So let's do one thing, minus mu naught I by 2 pi r is common. Okay, mu naught I by 2 pi r and minus also. So here I would multiply by pi and divide by pi. So minus minus plus pi minus 1 and I cap. So option number 2. Simple. Are yes? Simple. Now question number 43. In 43, a large drum having radius r is spinning around its axis with angular velocity omega as shown in the figure. The minimum value of omega. Okay. So this question is saying, okay, let me redraw it. This is cylinder and this M mass, it has M mass, capital M mass, and its radius is r and it is rotating by omega, angular velocity. Yes, the minimum value of omega, so that body of mass M remains stuck. Okay, minimum velocity. So let's talk about that M body only. Due to this rotation, it has centrifugal force mv square by r or m omega square. R is radius, so m omega square by m omega square r or mv square by r, right? That is rotating like this. So what will be the minimum speed? So this is what? This is equal to normal. Okay, simple. downwards pull is mg. Okay, so upwards force will be friction. Okay, and friction is what? Mu n. Okay, so mu value is given. Okay, so friction is mu n and n is m omega square r. So basically mg should be equal to friction. Simple. I'm writing mg should be equal to friction, and friction is mu and n is m omega square r. So cancel out m, omega square is g by mu r. So value of omega would be what? Root of g by mu r, root of g by mu r, 3. Understood? Again a simple problem. Okay. Now next is a body of mass 2 kg is moving along x direction such that its displacement is function is this h t equals alpha t square plus beta t plus gamma. Okay, so you do one thing, you write m meter somewhere here. Okay, because this displacement value is given in meters. Okay, where alpha is 1 meter per second square, beta is 1 meter per second and gamma is 1. So basically question is that its displacement is t square plus t plus 1. Simple. And this value is in meter. So could you tell me the acceleration? Double differentiation of this function would give me the acceleration. First differentiation, that is h dash or velocity, that would be what? 2t plus 1, and double differentiation h double dash or acceleration, that would be 2. And this value in meter, all the values are in meter and seconds. So this would be also in meter second or SI unit, 2 meter per second. Okay. During the time interval 2 second to 3 second, the work done on the force. Now simple, acceleration is constant. There is no involvement of integration. Why? Because force is same. Every time force is same, that means what? Acceleration is constant. Let's write force. Force is mass times acceleration. Mass is 2 kilograms. Acceleration is 2 meter per second. Force is 4 Newton. Now we need displacement. So once you put 2 seconds, at 2 seconds x or position vector was 2 to the 4 plus 2 6 plus 1 7 meters. At t equal to 2 second, x was or the object was at 7 meter position. At t equals 3 second, h was t square, 3 3 is 9 plus 3 12 plus 1, right, 13. So h will be at 13 meter. Okay, so displacement is what? Displacement is 13 minus 7, 6. So work is what? Force into displacement, 4 into 6. So that gives 24 joules, right, in SI. So which option is correct? Third option. Simple. Okay, now this is a good question. Why this is a good question? As shown in the diagram, when the incident ray is parallel. Okay, this is not a good question. This is also a simple question. Base of the prism, the emergent ray grazes along the second surface. Okay, so this is the emergent ray. So this is what? This is TIR, total internal reflection. Let's redraw it. First surface, incident ray, 45. These are parallel. Okay, so this is also 45 and this is 90 angle. So I angle, incident angle is also 45 degree, right? 45, 45, 45. It was 45 plus 45, 90. Okay. Then we have this. So, okay. And let's say this is R angle. Okay. This is R basically. But this complete angle is 90. Okay. And after this, this is going in this direction. So again normal 90 angle. So basically this is IC, critical angle. This is critical angle and we need the value of theta. The very easy problem. How, sir? So sin IC will be what? Sin IC will be 1 by mu, right? Are yes or no? Okay. So 1 by root 2. Mu is given root 2. Sin IC is 1 by root 2 means IC is 45 degree, right? If the refractive index, okay. So we wrote this value, this is 45. Okay. If this is 45, okay, so is there any need of this angle? Okay, yeah, we need. If this is 45, this angle is also 45. Okay. Then R angle. So basically sin 45 degree upon sin R equals also mu root 2. Yes or no? Sin 45 is what? This sin 45 is 1 by root 2. So sin R is sin 45, that is 1 by root 2. This is in numerator, this is in denominator. 1 by root 2 into 1 by root 2, that is 1 by 2. And sin 1 by 2 means what? Sin 1 by 2 means 30 degrees. So this is 30 degrees. 30 degree, then this is what? This is 60. Okay. Now if this is 60, this is 45, so total 105, right? So this angle would be what? 180 minus 105. 105, so 75. So this angle is 75. This angle is 75, 45. So theta would be what? 180 minus sum of 75 and 45. 75 and 45 is 120. So theta angle is 60. See, pure geometry based question. If you know the mathematical geometry, question is very simple. That question number 46. In 46th question, we have an electromagnetic wave of frequency 100 megahertz. Okay, 100 megahertz propagates through a medium of conductivity, and sigma is, okay, conductivity is given, sigma mho per meter. The ratio of maximum conduction current, okay, current density to maximum displacement current density. So the ratio of maximum conduction current density upon maximum, both the values are maximum displacement current density. Okay, so you guys are aware that value is sigma upon epsilon naught omega. Basically that is epsilon only, but as epsilon is not mentioned, okay, so I am going to take epsilon naught only. Okay, so let's write here sigma value is 10 mho per meter, okay, in SI unit. Then epsilon naught, so from here epsilon naught would be 1 upon 4 pi into 9 into 10 raised to 9. Okay. And all the units are in SI, so that would be also in the SI unit. Now put that value here, so that value would be somewhere here. Okay. Okay. 9 4 is 36. 36 pi into 9 into 10 raised to 9. Okay. Now omega. So omega, an electromagnetic wave of frequency 100 megahertz, but we need what? The angular frequency. First of all, this is frequency, and that is 10 raised to 8 hertz. Simple, because 10 raised to 6 plus 10 raised to 2 is 10 raised to 8. Okay. Then 2 pi f is omega. So let's write that here. 2 pi and f, frequency is 10 raised to 8. So pi cancelled out. Okay. Then only 10 is left there. Then 18. Now anything else? Anything is left? Okay, nothing is left. So array yaar, we did a mistake. What was the mistake? Actually, I wrote this 4 into 9 is 36 here. Yes, but again I wrote 9, sorry. So basically 9 is not there. Yeah, now everything is fine. 18 into 10 into 10. So 1800. Okay, simple. See, don't do calculation mistakes. Questions are pretty easy. While you are attending your next exam, keep in mind that that's not a hurry. You can look at the question for 10 more seconds, but mark it correctly. Okay. Now, the terminal velocity of a metallic ball of radius 6 mm is in a viscous fluid 20 centimeter per second. The terminal velocity of another ball of same material and having radius 3 mm. Okay. So basically, we have these two balls, 3 mm radius, 6 mm radius. So generally I would do it by r and 2r. This is very simple. Okay. 6 mm 2 mm. Okay. And its velocity is 20 centimeter per second. And what would be its velocity? Those are going downwards in a viscous fluid. So again, I have already derived in one of the questions, I think 27th or 8th question, that mg downwards, mg equals buoyant force rho vg plus 6 pi eta r v. Eta is same, because same viscous fluid, and this is what? Sigma vg, right? Why? Because let's say sigma is the density of this ball. So sigma minus rho, v is 4 by 3 pi r cube, and into g equals 6 pi eta rv. So what I'm trying to say, this value is constant, only r cube and r. So rv proportional to r cube. So v is proportional to r square basically. Now see, if r to r, so if its velocity v, then its velocity will be what? Square of 2r, means 4 times 4v. Then its velocity would be what? 20 by 4 or 5 centimeter per second. Yes. So answer is 5 centimeter per second. Did you understand? Yes. Okay. The next question is, a particle having electric charge 3 into 10 raised to minus 19 coulomb and mass this much, and kg is accelerated by applying an electric potential of 1.21 voltage. Okay, wavelength of the matter wave associated with the particle is alpha into 10 raised to minus 12. The value of alpha is, okay, so this is also a simple question. A particle sorry, a particle having electric charge that is 3 into 10 raised to minus 19 coulombs and mass is this. Okay, first of all, charge, mass, okay, accelerated by applying an electric potential 1.21 volt. Okay, wavelength of matter wave associated with the particle is, okay, wavelength, first of all, wavelength. So wavelength associated with this particle will be Planck constant h by p, momentum, okay, and that is what, h upon root 2 m kinetic energy, because you know kinetic energy is half m v square multiply with m divide by m half m v square by m, so p square by 2m is kinetic energy. So p square is 2m kinetic energy and p is root 2m kinetic energy. Okay, now let's put the values. 6.6 into 10 raised to minus 34. Okay, now 2m in the root, 2 mass is given, okay, 10 raised to minus 27, 2m k. So k will be what? The energy. Energy will be qv. Q is charge, that is 3 into 10 raised to minus 19 into voltage, that is 1.21. Now 2 3s are 6. We have 2 3s are 6 and 6 twice. So 6.6 into 10 raised to minus 34 and 6 is outside of the root. How? So let me change the color of pen. Okay, 6 3 2, 3 2 is 6, 6 is out. Then now let's do one thing, remove this point and increase 2 zeros here, so that would be 121, square of 11. Okay, so now we are left with 10 raised to minus 27, 10 raised to minus 19 and 100. So this will also give 10 raised to minus 2. So 10 raised to minus 21 plus 10 raised to minus 27. So this value is left 10 raised to minus 27, 28, 48. So 48 means 10 raised to minus 24. Minus 24. Then remove point and 10. 11 6 66. Okay, now this value would be what? 10 raised to minus 23. This will go upside, so 10 raised to minus 34 into 10 raised to plus 23, so this gives 10 raised to minus 11. Okay, and alpha value is given, the wavelength value, this is what value of wavelength in meter, 10 raised to minus 11. So could I write it as 10 into 10 raised to minus 12 meter. So alpha value is what? Alpha value is 10. Understood? Are you understood? 10. Simple. Next question is, in a Young's double slit experiment setup, In a Young's double slit experiment setup, the two slits are kept 0.4 mm apart and screen is placed at 1 meter. So, okay. So different, okay, distance between slits is 0.4 mm and distance between that screen, so that screen is 1 meter apart from these slits. Okay, 1 meter from slits. If a thin transparent sheet of thickness 20 micron, you introduced one thick sheet and its thickness is 20 micron. Its thickness is 20 micron is introduced in front of one of the slits, then center bright fringe shifts by 20 mm. So this center bright fringe shifts by 20 millimeter. Okay, the refractive index. Okay, so what is happening, basically we are finding path difference. So whatever ray will pass through this fringe, okay, sorry, this T thickness sheet, what will happen, that will travel mu T more, yes or no? So basically that shift formula is what? So that shift formula is mu minus 1 into T into D by D. Okay, so this is given delta Y 20 mm, 20 into 10 raised to minus 3. Okay, 20 into 10 raised to minus 3 equals, so what do we need? The refractive index. Okay, mu minus 1. T is how much? 20 micron. 20 into 10 raised to minus 6. 20 micron. D 1 meter. Separation is 1 meter. And small d is 0.4. 0.4 millimeter means 10 raised to minus 3. Now 10 raised to minus 3. 10 raised to minus 3. So it will go in the numerator. So that will become 10 raised to minus 6. So you can cancel out 10 raised to minus 6 with 10 raised to minus 6. Okay, what could I do now? 20 and 20, yes. So now is something is left. Okay, 0.4 is there. So mu minus 1 is, this 0.4 will go in the numerator. So 0.4 into 1. Now mu is 1.4. Okay, and that is alpha by 10. Alpha by 10. So alpha value is 14. Answer is 14. Simple. Okay. See, in this shift we have the simple ones or moderate ones. Difficult questions are not there in this shift. So now let's see the question number 50. A diatomic gas. Gamma is given. Gamma is given, that is what? 7 by 5. Does 100 joules of work. Work is 100 joules. Thermodynamics. When it is expanded isobarically. Isobarically PV equals nRT, right? And isobarically pressure is constant. So P delta V is nR delta T. Very simple. Then the heat given to the gas is, so basically let's say this is the system, this is piston. From here you give the heat Q heat, change in internal energy delta U, and some work is done. So Q equals delta U plus W. Yes or no? Sorry, W. This is thermodynamics first law. We are aware of that. Now just apply the simple things. What do we need? Then the heat given. We need heat given. Simple. Q equals delta U. Change in internal energy. And FR by 2 delta T. Plus work. Work is what? NR delta T. NR delta T. Okay. I took common NR delta T. So left with F by 2 plus 1. And NR delta T is what? Work. And work value is given 100 joules. So I would write here 100 joules into F by 2. This is what? Gamma. Degree of freedom for diatomic gas is 5, sorry. That is 5, right? So write 5 here, 5 by 2 plus 1. So 5 by 2 plus 1 is 7 by 2. 7 by 2 into 100. 7 by 2 into 100 means 50 into 7. So 350 is the final answer. 50 into 7 is 350 joules. That's the given heat to the system. Did you understand? Okay. Now, thank you so much guys for joining us at Infinity Learn by Sri Chaitanya. And yeah, I want to say just one thing. When you are going to write your exam the very next time, so always do one thing. Before you are marking any question, just check whether it is correct or wrong. Because that is not the waste of time if you are investing your 10 seconds. That means you are securing those 4 marks. Those 5 marks, I would say 5 marks. Why 5 marks? Because plus 4 minus 1, 5 marks. So please recheck when you are marking the answer. Okay guys, have a very good day.